In this video, we're going to look at intro material. We're going to look specifically at the section on coordinate systems. Coordinate systems. Okay, so from the website, we're looking at the intro material. Click on this file, and it will bring you to this document. And we are on the section on coordinate systems, which is related to section 11.1 and 11.2 from our textbook. Okay, so let me get into you can read here. I think the first thing to notice is the definition according to the textbook, according to our notes here. A coordinate system on the space R2 or R3 consists of two pieces of information. It consists of the choice of a specific point, which is called the origin, and consists of two or three vectors. If you want a coordinate system on R2, you need to choose two specific vectors. And if you want a coordinate system on R3, you need to choose three specific vectors. So the easiest thing to do is to start with what's called the standard coordinate system. Okay, this is probably the one you've known and loved without having really talked about it. So a coordinate system, and let's just for simplicity and drawing pictures and stuff, let's just look at a coordinate system, the standard coordinate system on R2. So the standard coordinate system on R2 consists of an origin, and it consists of two vectors. Okay, two vectors. Because it's the standard coordinate system, we want to choose our origin as the standard origin 0, 0. And our two vectors, which I'll call E1 and E2, which your book often calls I and J with bold faces. It's hard for me to draw that, so I and J. Okay, where E1 is equal to the vector 1, 0, and E2 is equal to the vector 0, 1. So here is our standard coordinate system. It is an origin and these two vectors. Okay? So if you would like to represent that as a picture, okay, we have in the xy plane, because we have a coordinate system on R2, our coordinate system consists of an origin, 0, 0, and it consists of two vectors. Here is E1 and here is E2. E2 and here is E1. And if you were to continue this process, they keep stepping in different directions. We know from our vector operations that 2E1 is 2 comma 0. It's twice times E1. Okay, so that's two steps in the E1 direction. If you go minus 3E2, that's minus 3 times 0, 1, which will be 0, negative 3, which will be negative 3 steps, 1, 2, 3. Right here is minus 3E2. So you can see that if we continue out this grid system, the standard coordinate system defines a grid, a rectangular grid system. Okay? Now, once you have this coordinate system, if you're given any other point, say, let's say point P is equal to 2, 3, right? Once you have this coordinate system, that is what you need to use to start to draw your vectors. So what I mean by that, if you choose a point P and you want to come up with the vector relative to this coordinate system, the vector of P relative to the coordinate system that we've picked, well, you have to use the origin that we've drawn, so you must draw things from this origin to the point P. Well, that's convenient. O to P is just the vector 2 to 3. Now, Once that's using the origin of the coordinate system. If you want to use the vectors of the coordinate system, that will let you take, here's 1, 2, 1, 2, 3. So here's your point P up here. We've now represented, relative to this coordinate system, we've come up with the vector to that point. That is the straight line vector. If you could go directly from the origin to that point, you should go along this vector. But if you want to break that process into a series of steps, you need to use the other part of your coordinate system, which is the two vectors, to write this as something times something A times E1 plus a number B times E2. What we're going to do is take the instructions. We want to go to the point from origin to P, and we need to break that into a series of steps. So this will give us A times 1, 0 plus B times 0, 1, just using the definition of what vectors we had chosen for our coordinate system, and these were chosen. This will give you A times 0 plus B 0 comma B. And we know how to multiply and we know how to add vectors, so this will be A comma B. So this tells me that the vector P, when we drew this from our standard coordinate system, the vector P was 2, 3. So this tells me that A is equal to 2, comparing entries here, and B has to equal 3. Okay. This is almost such a simple example, which is why it's nice about the standard coordinate system. So this says that if you want to go from the origin to that point P, if you want to go and that end up, if you could go straight there, you should follow this vector P. But if you can't go straight there and you must break it into a series of steps, you should go 2 times E1 plus 3 times E2. And that will basically say you follow the grid 2 steps in this direction and 1, 2, 3 steps in the E2 direction. So the vector 2, 3, taking these numbers right here and putting them into a vector, this is what's called the coordinate vector of the vector P relative to the coordinate system O, E1, E2. So if you want to find the coordinate vectors, you need to take the vector that you were trying, the vector, and split it up into its component pieces, so the E1 and the E2 vectors, and you need to find these numbers A and B. Once you find those numbers A and B, you put those into a vector, and those are the instructions that you need to follow. Go A steps in the E1 direction and B steps in the E2 direction. So this is really rather, almost a no-brainer of an idea when you're in the standard coordinate system. It's kind of hard to think of anything how it could have worked out otherwise. But if you try a non-standard coordinate system, okay, a non-standard coordinate system. Let's bring up a picture here. Okay, so here's what we're doing. We're talking about coordinate systems, and now we're in the non-standard coordinate system section. But let me move to a picture here, and let's take a look. Okay, so here, what we have on the screen is our non-standard coordinate system. This is the red coordinate system. So notice that what we've got here, we're going to have a different set of gridding. Okay, so the black is our standard coordinate system. Our non-standard coordinate system, the red coordinate system, is given by an origin, and it's given by 2 vectors. Okay, the origin for this problem is the point 2, 2, 2, 2. And the 2 vectors, let's call them V1, and V1, let's call that the 1, 1 direction. V1 is 1, 1, and V2 is equal to 1, negative 1. So there's your non-standard coordinate system. Okay, here's the origin, and here are the two vectors. Okay. Now let's do this example real quick. Actually, let me just pick some other example here. Okay, so let's take, now that we know that this is our origin, let's call that A. This origin A and the vectors here. So now let's pick some point P. Let's pick some point out here. How about the point 4, 4, 4? Let's pick the point 4, 4. Okay, so this point right here. Now, if you want to find the vector from this coordinate system to that point, you have to use the origin that you chose. So the origin to this point P will be P minus A. So drawing the vector from this origin to this point P, and you should get the vector 2, 2. Okay? This point P minus that point A. Okay? So here's your vector A to P. So if I could draw a vector from this point to that point, I would draw a vector right there. Okay? So I guess I can draw that over here. So our origin, here is our origin A, and the point P was over here, point P. So with our coordinate system, we have to draw vectors from that origin, so our vector is 2, 2. Okay. But we have our coordinate system here, the other part of our coordinate system, which is the two vectors. Okay. So the question is now, we want to take the vector A to P, which is 2, 2. And if you could go from this point and you could fly directly to that point in a straight line, you should just follow the vector 2, 2. The problem is that we can only use the two legs of our coordinate system, so we want to break this up into something times v1 plus something times v2. Okay. The vector v1 is 1, 1, and the vector v2 is 1, negative 1. So again, your goal is to solve for A and B so that you can figure out how to go from this point A to this point P using only these directions, using only the directions v1 and v2. So, the way we're going to do that, I'm going to use my vector scalar multiplication. A times 1, 1 is AA. B times 1, negative 1 is B, negative B. I'm going to add these together to get A plus B, A minus B. Okay. And we want this to equal the vector 2, 2, because I'm trying to split the vector A to P up into its pieces. Okay. So this tells me that A plus B has to equal 2, and this tells me that A minus B also has to equal 2. I'm going to add these together to get 2A is equal to 4. A has to be equal to 2. If A is equal to 2, B has to equal 0. So what have we just done here? We have just shown that the vector A to P, which is 2, 2, can be written as 2 times v1 plus 0 times v2. v1 was 1, 1, and v2 was 1, negative 1. So this tells me that if I want to go from this point A to this point P, I have to go in the straight line direction of 2, 2. Or you can break that into the steps. You can go 2 steps in the v1 direction and 0 steps in the v2 direction. So your coordinate vector of the vector AP relative to the coordinate system v1, v2 is 2, 0. Okay, so let's see if we can look at another picture here. Okay, let's do one more example in a non-standard coordinate system. So here we have our same non-standard coordinate system. We have the point A, our origin is 2, 2, and we have the vector, our first leg of our coordinate system is 1, 1, and our second leg of our coordinate system is 1, negative 1. Okay. And here is a point over here, 3, 5. Let's say that the point is 3, 5. Okay. And your job is to find the vector A to P, and then to decompose this vector A times V1 plus B times V2. Now I think I can see the answer here. Let's take a look. The vector A to P. That should be the vector from this origin directly to that point P there. So A to P, that would be P minus A. P is 3, 5 minus 2, 2. And that will give you 1, 4. So 1, 4 is the vector. If we could go right from this point A, the red point, to this point blue with the point 3, 5 and go there, fly there directly, we would have to go 1, 4, 1 over and 4 up. The problem is that we're not allowed to do that, or I'm imposing the restrictions that we have to split this up. The only directions you're allowed to go in are the 2 red arrow directions. So that's A times V1 plus B times V2. Maybe you can spot the answer. If I go from this point to that point, and I'm only allowed to go in the red directions, it looks like I can go 2 steps in the V1 direction, and it looks like I can go backward V2. So it looks to me that just from the picture, A would be 2 and B is equal to negative 1. Okay? And you should be able to check that, right, by doing 2 times 1, 1, and adding negative 1 times V2, which is 1, negative 1. So that was our choice of V1 and V2. So that would give you 2, 2 plus negative 1, 1. Add those together and you'll get 1 and, let me see, 1 and 3? Oh, sorry, 5 minus 2 is 3. I'm an idiot. There we go. So notice that once you take the vector A and the A to P, and then find your coordinate vector, so your coordinate vector of A to P relative to the coordinate system V1, V2 is 2, negative 1. Okay. So if you go, the coordinate vector are the actual instructions that you need to do to go from this point to that point, following only the red arrows. So there's lots of other examples here to follow, and we'll then pick up with our textbook talking about dot products and other properties of vectors. So that ends this section on coordinate systems. I'll leave you to really kind of look at this example algebraically and then compare to some of the homework problems that are given. For example, a problem like this to test whether or not you have an understanding of computing vectors and also computing coordinate vectors.